You know that panorama feature on your phone? You snap a picture, move your phone, and somehow it creates this incredible super wide photo that just looks perfect. It seriously feels like magic. But today, we're going to pull back the curtain and see the really clever tech that makes it all happen.
So yeah, that's the big question, right? How does your phone take two completely separate pictures and stitch them together so you can't even see the seam? Well, it's not magic, but it is a really fascinating mix of computer vision and some clever math, and that's exactly what we're going to break down.
Let's start by framing this as a puzzle. We can call it the panorama puzzle. At its core, the problem is this. How in the world do you teach a computer to look at two different, overlapping images and line them up perfectly?
So here's the mission. We have a left image and we have a right image. They were taken from slightly different angles. The computer's entire job is to figure out exactly how to smush these together so the final result is totally seamless.
Now, to solve this puzzle, we first have to get our heads around a really fundamental idea. A computer sees the world totally differently than we do. And I mean, completely differently.
Okay, this slide is everything. On the left, that's what we see. Our brains instantly recognize it. It's a mountain, there's snow, some sky. We get the context. But on the right, that's what a computer sees. It's just a giant grid of numbers, a value for every single pixel. It has no idea what a mountain is. So, how does it find the same mountain in two different photos if all it sees is data?
Well, it has a pretty smart three-step process. First, it scans both images looking for features. Think of these as interesting, easy-to-spot landmarks, like the sharp corner of a rock or a unique patch of texture. Then, for each of those features, it creates a digital fingerprint, a unique description of the pixels around that point. And finally, it just compares all the fingerprints from image 1 against all of the fingerprints from image 2 to find any that look like a match.
All right, so we've got a whole list of points that might be the same across both photos. The next step is to figure out the exact mathematical relationship between the two images. This is where the magic really starts to happen.
Just think about moving a piece of paper around on your desk. You can slide it up, down, left, or right. That's called translation. Or you can spin it. That's rotation. The connection between our two photos is basically just a combination of these simple movements, plus a little bit of a perspective shift.
And what's so cool is that we can bundle all of that movement, the sliding, the turning, the perspective, into one single mathematical recipe. It's called a geometric transformation. You can just think of it as a set of instructions that tells every single pixel in the right image exactly where it needs to move to line up perfectly with the left image.
Okay, this all sounds great so far, right? But there's a catch, a big one. That feature matching process we just talked about, it's not perfect. In fact, it gets things wrong a lot. And this brings us to our biggest challenge. How do we find the good matches when they're buried in a sea of bad ones?
And this right here, this shows you the problem. Every red dot is a potential match the computer found. You can see that all the correct matches form that nice, clean diagonal line. But look at all that other stuff. That's just noise. We call those outliers. And they're all just bad matches that are going to confuse our algorithm. Now, if you try to use a simple method to find the pattern here, like trying to draw one line that gets as close as possible to all the points, it gets totally thrown off. It tries to please all those noisy outliers, and you end up with a line that doesn't actually fit the good data at all. This would give us a horribly warped panorama.
So we need a hero, and that hero's name is RANSAC. It stands for Random Sample Consensus, and it is a brilliant algorithm designed for this exact problem, finding the real signal when it's buried in a whole bunch of noise.
So how does RANSAC work? Well, instead of trying to look at all the data at once, it starts really small. It picks just 2 points, completely at random, and draws a line between them. Now, most of the time, it's going to pick at least one bad point, so this first guess is probably way off.
But here's where the consensus part comes in. RANSAC then looks at all the other points and counts how many of them agree with this proposed line, how many are close to it. For a bad guess like this one, not many points are going to support it, so it gets a really low score.
Then it just throws that line away and starts over. It picks 2 new random points, draws a line, and counts its supporters. And it does this again and again and again, hundreds, maybe thousands of times. All the while, it's keeping track of which line has gotten the most votes so far.
And then, eventually, just by pure random chance, it's going to pick 2 points that are both good matches. And when it draws a line between those two, suddenly a ton of other points are going to agree with it. That line will get a huge score.
After all the trials, RANSAC just presents the line that got the most votes. It found the true pattern simply by ignoring all the noise.
So we did it! We found the true transformation. The hard part is over. Now we have everything we need for the grand finale, actually stitching these two images together.
And this is where that math finally creates our picture. Step 1, we use that transformation we found with RANSAC to warp the second image. We're basically telling the computer to stretch and shift it until it lines up perfectly. Then, step 2, we just blend them. We average the pixels where the two images overlap, and that makes the seam completely disappear. And here it is, the final result. We started with two totally separate photos and a whole bunch of messy, noisy data. But by finding features, using the brilliant RANSAC algorithm to find the true relationship, and then a little math to warp and blend, we get a perfect, seamless panorama. The magic was just a really, really clever algorithm all along.
This whole process, finding patterns in messy visual data, is really the bedrock of almost all modern computer vision, which kind of leaves you with one last big question. If we can teach a computer to see the hidden connection between two photos, what else can we teach it to see?